In this lesson, we're going to focus on multiplying radicals, and in particular will be square roots. So in previous lessons, remember we used the product rule in many of the prior lessons to this. And so we use the product rule for radicals to simplify radicals. So remember the product rule says that if you have the square root of a product of two or more factors, then you can rewrite it as a product of the square root of each factor. That's what this is saying. And again, remember we're assuming that a and b would be positive numbers or zero, so that way the square root of a and the square root of b is a real number. So basically a cannot be negative and b cannot be negative. So remember, as an example, we did something like this, and this was an easier example now for you. But remember this, if I want to simplify the square root of 18, then what I did was I looked for a perfect square that goes in 18. And remember, we always use the largest possible. And so I can rewrite the square root of 18 using a product rule as the square root of 9 times the square root of 2. And that's what this says. Okay, because remember, the square root of 18 is the square root of 9 times 2. And so based on what we see here, I can write it like the square root of 9 times the square root of 2. And then we can simplify the square root of 9 in this case. And so I get 3 square root of 2. And remember that the square root of 2 I cannot simplify any further because the only perfect square that goes into 2 is 1. Okay? All right, so that was a quick review from a previous lesson. Now, in this lesson, we're going to use the product rule. We're going to use a product rule to simplify products of radicals. And so basically we're going backwards in this case. So if you notice, I'm saying that if I have the product of two or more square roots, then I can write it as one square root by just multiplying the radicands. So if I have the square root of a times the square root of b, then I can write it as one square root by just multiplying, by just having the radicand be the product of these radicands. Now remember, this only applies if we're dealing with the same index. So in this case, I'm looking at square root. If this were cube root, it would still apply. Cube root, I can write it as 1 cube root. Fourth root, I can write as 1/4 root, and so on. Okay? All right, so in words, this is what this statement says right here. So this statement says the product of the square root of two numbers, so the product of the square root of two numbers is the square root of the product of the two numbers. So basically you take those two numbers and you multiply them together, and that's your radicand. All right, so we're going to use this in the next in this lesson. So let's look at the examples. So the examples will say, the directions rather, will say something like this. It will say multiply. And then when you multiply, you want to make sure you simplify if possible. Simplify if possible. Okay? All right, so here's an example. Number 1. We have the square root of 5 times the square root of 2. Now again, in order to use the product rule, in order to use this rule here, the indices must be the same, first of all. And they are, because we are dealing with square roots in this case. So the index is 2 in all cases. Okay, so that's important. So notice it's a square root. So I can write this as 1 square root by using the product rule. And the product rule says all I need to do is multiply the radicands together. And so I get the square root of 10. Now once you get to that point, you got to ask yourself, can I simplify? Can you simplify? That's the question. All right, and so notice that we're dealing with square roots, so you can look for perfect squares. Is there a perfect square other than 1 that will go into 10 evenly? And the answer is no. So that's your answer. And that's all it is. Okay? So that's the only new thing, and then the rest is just using information that you learned in the past. Okay, number 2. We have the square root of 7 times the square root of 7. All right, so the square root of 7 times the square root of 7, the indices are the same, so that means I can write it as 1 square root using the product rule. And the product rule says I take these radicands and I multiply them together. So 7 times 7 is 49, so I get the square root of 49, right? Now the question is, can I simplify? Once you get to that point, can you simplify? And the answer is yes, because 49 is a perfect square. So what's the square root of 49? 7. Okay, because 7 times 7 is 49. Now, some students have a habit of saying the square root of 7. That's not true. Okay, square root of 49 is not the square root of 7. It is 7 only. All right, number 3. So see, it's not that bad at this point, right? Okay, let's look at the square root of 8 times the square root of 3. Okay, so the square root of 8 times the square root of 3, I get, so I'm going to use a product rule. So I can write this as 1 square root. So that'll be 8 times 3, right? Which is the square root of 24. Okay, now, can I simplify the square root of 24? Is there a perfect square other than one that goes into 24? And let's use the largest. And the answer is yes, because I can rewrite the square root of 24 as the square root of 4 times 6. So you see, I'm kind of using the product rule twice. So I'm using, to go from here to here, I'm using this, and now I'm going to use this. Okay? All right, so then this becomes the square root of 4 times the square root of 6. And so the square root of 4 is 2, so I get 2 square root of 6. Okay? So notice I use the product rule here, and then I use the other version of the product rule here. Okay? So again, product rule used twice. So keep that in mind. In these cases, I didn't have to. Why didn't I use, when I got to this point, why didn't I use this? Well, I didn't use this that we've learned in previous lessons. I didn't use this because I couldn't simplify this further. This right here, I couldn't simplify the square root further. Okay? Now, here, I mean, that was just a perfect square. So there wasn't really anything to do. So the square root of 49 is just 7. Okay, number 4, we have the square root of 10x times the square root of 2x. Okay? And so using the product rule, I can write this as 1 square root. Okay? And so that's going to be the square root of 10 times 2 is 20. Y'all agree? And x times x is x squared, right? Okay. Now, I am going to now use, so this is this version of the product rule. So I wrote as 1 square root. Now, once you get to that point, you got to ask yourself, can I simplify this? Can this be simplified? Well, that's where we go back to information we've learned in the past. So I have to look at this now. So I'm going to rewrite this as the square root of 20 times the square root of x squared. So that part should be familiar because we've had that in previous lessons. So I got to see if I can simplify the square root of 20, right? So what's the largest perfect square that goes into 20 besides 1? Okay, 4. So I'm going to rewrite this as the square root of 4 times 5, right? Okay. And then you remember the square root of x squared? If I go off to the side over here, do you remember how to simplify a variable raised to a power? So first of all, can I simplify this? Yes or no? Yes, you can, because the exponent is greater than or equal to the index, which is 2. So remember how we did this? We said whatever goes here, we said whatever's here, that times itself is x squared. So what times itself is x squared? It's just x. And again, we're assuming that all these variables represent positive numbers. So we don't have to worry about absolute values. So this right here is x. So I'm up to that point, right? Now all I got to do now is use the product rule here to rewrite this. So that's the square root of 4 times the square root of 5 times x. And so the square root of 4 is 2. So I get 2 square root of 5 times x. And you can leave your answer like this. But remember, you got to be careful how close you put that x, because you don't want to extend the square root symbol to where it looks like the x is underneath. So this is not correct that I'm about to write. So some students do this. They'll write it like this. And you see, it kind of looks, well, it is x is underneath. And even if you kind of don't put this square root symbol that far along, sometimes they'll put it close enough to where I can't tell whether it's underneath or not. So that's why it is always best when there's a square root involved or a radical involved to put the variable between the 2 and the square root symbol. So it's better to write it like this. So that way there's no confusion. That's the only reason. So there's no confusion. Okay? All right, so notice we use the product rule multiple times. Okay, number 5. Let's do number 5. So in number 5, we have this. We have 3 square root of 7 squared. 3 square root of 7 squared. All right, so remember what that means. First of all, that means 3 square root of 7 times itself, right? 3 square root of 7 times itself. Okay, so let's think about that. All right, well, I know that 3 times 3 is 9, so that part's easy, right? 3 times 3 is 9. And then let's look at the square root of 7 times the square root of 7. So this right here, y'all agree? Okay. Using the product rule, I can write this as 1 square root. And so when I do that, I get 9 times the square root of 7 times 7. So that becomes 9 times the square root of 49, correct? And then can I simplify the square root of 49? Yes, because 49 is a perfect square. So it becomes 9 times 7, and 9 times 7 is 63. So there's your answer. Okay? All right, let's do number 6. Number 6, let's suppose we have 4 times the square root of x squared. 4 times the square root of x squared. Okay, so just like number 5, I can rewrite this as 4 square root of x times 4 square root of x, correct? Okay, so remember, you have 4 factors here. You have 4 square root of x, 4 square root of x. The order in which you multiply does not matter. So if you look at this, I'm going to multiply these two 4's together first. So 4 times 4 is 16. So I get 16, right? and then if you look at what's left, I have the square root of x times the square root of x. So I'm going to use the product rule on this now to write it as 1 square root. And so this becomes 16 times the square root of x times x, just like that. And then x times x is x squared. So I get 16 square root of x squared. And then remember, you got to ask yourself, can I simplify the square root of x squared? So the square root of x squared. So remember, whenever you're dealing with square roots and you have a variable raised to a power, if it's even, if that exponent is even, that's the easy kind. So you get x, so this is x, and it's x because you get x times x is x squared. And remember, all we did was just take this exponent and divide by the index 2. So 2 divided by 2 is 1. So you see x to the first. All right, so the answer is going to be 16x, and that's it, 16x. All right, number 7. We have the square root of 6x to the 7th times the square root of 2x cubed. So 6x to the 7th times the square root of 2x cubed. Okay, so using a product rule, see you have a product of 2 square roots. So I'm going to use the product rule to write it as 1 square root. So I get the square root of, and I'm going to rewrite this as 6 times 2, right? Times x to the 7th times x to the 3rd. And I could go from here to here. You can skip some steps. Did you have to say 6 times 2? No, most of you knew right away, if not all of you knew, that 6 times 2 is 12. So if you wanted to, you could have gone directly to square root of 12. Okay, so you can go from here to here. And then you could have also gone from x to the 7th times x to the 3rd. So when you multiply like bases, you add exponents. So all of you knew that x to the 7th times x to the 3rd is x to the 10th. Okay, so you did not have to go and write this step. All right, you could have gone directly from here to here. Okay, but now we got to use a product rule again. So I'm going to rewrite this as the square root of, as a product of 2 square roots now. So I get the square root of 12 times the square root of x to the 10th. Okay, so if you look at what I had earlier, see I had the square root of 6, right? Well, there's no way I can simplify the square root of 6, and there's no way I can simplify the square root of 2. So we have to use a product rule first, and then we get the square root of 12, which I know I can simplify now. All right, so at that point, this is where you simplify. So let's go off to the side, and well, we can do it here. What perfect square goes into 12 besides 1? Okay, 4. So it'll be the square root of 4 times the square root of 3, right? That's this. Okay, times, and then let's go off to the side. I want to kind of talk about this. That's even. The exponent's even, so that's the easy kind. So you can tell me right away what that exponent should be. What is the square root of x to the 10th? So x to what power times itself is x to the 10th. Okay, x to the 5th. And remember, all we do is just take the exponent, divide by 2, and that's how we get that 5. So the x to the 5th. And so all I got to do, almost done with this one, all I got to do is now simplify this. With the square root of 4 is 2. So I get 2 square root of x, square root of 3. Square root of 3 times x to the 5th. Or, if you want to write the square root at the end, as the last factor, you can say 2 x to the 5th square root of 3. Okay? Either one of those is fine. All right, so that was number 7. Let's look at number 8. So number 8, we have, number 8, we have the square root of 3xy to the second times the square root of 27xy. Okay? So the best way to deal with these so far is to go ahead and use the product rule and write this as 1 square root and then simplify. Okay? So you always want to simplify at the end. You want to make sure your answer is in simplified form. So if I use a product rule now, I'm going to get 3 times 27, right? And then x times x, y'all agree? And then y squared times y. Okay? So 3 times 27, then use your calculator with that. 3 times 27, if you can't think about it real quick, just use your calculator. 3 times 27 is 81. So I get the square root of 81. X times x is x squared. Y squared times y. Remember, when you multiply like bases, you add exponents. 2 plus 1 is 3. Y cubed. Okay, so that's where I'm at. Now, I'm going to simplify this. And to simplify this, that's where you go back to previous lessons. So I'm going to use the product rule to rewrite this again. So this is going to be, I'm going to go this way. So this is going to be the square root of 81 times the square root of x squared times the square root of y cubed, right? Okay, let's get about the square root of 81. 81 is a perfect square. So what times itself is 81? 9. What's the square root of x squared? X. Okay, let's talk about the square root of y cubed. Let's talk about that. So remember, if the exponent's even, that's the easy kind. If the exponent's odd, remember what you got to do. And remember, we're taking the square root here. So you're gonna do it the way we've been talking about it. So you're gonna rewrite y cubed. You're gonna rewrite y cubed. So that way, when you rewrite it, you're gonna make sure that one of your exponents is the largest number less the largest integer, the largest whole number less than 3. That's even. So that will be 2, right? So I get y squared times y. And y'all agree that y squared times y is y cubed? So now I'm going to use the product rule on this. So I get the square root of y squared, square root of y. And then this is y now. Y times y is y squared. So this becomes y square root of y. And so that goes here. So this is y square root of y. And so your answer is 9xy times square root of y. And that's it. 9xy square root of y. Okay? All right, so that's number 8. And by the way, if you want to rewrite it as, and remember, always put the factor that's a number at the beginning, and we tend to put the square root at the end. But if you wanted to say 9yx, that's fine, but we just go ahead and put it in alphabetical order. So you could have said 9yx square root of y. Does not matter. Okay, but we always, for something like this little part here, we tend to put this in alphabetical order. Okay, so that was number 8. Okay, let's look at number 9. Number 9, we have this. So see, it's not that bad. It's just using the product rule, and you have enough knowledge to get you through almost all of this. So in number 9, we have the square root of 18 times x to the 4th, y to the 4th, times the square root of 2x squared, y. Now, some of you might say, well, can I go ahead and just simplify this first and then simplify what I can here and then multiply those using the product rule? Yeah, you can. And we could have done that in some of the other problems, but the problem is it becomes so messy, so messy. You have so many things going on here that you may end up missing something. So the best approach is instead of simplifying the square root of 18 and then seeing that the square root of x to the fourth power is x squared, the best approach is to go ahead and multiply those two radicals as 1 and then simplify. Okay? That's the best approach. Okay, now, so I have the square root of 18 times 2, right? And then notice, you know right away that's 36, isn't it? And which is a perfect square. So again, it helps to multiply first. And then I have x to the fourth times x squared, right? And then I have y to the fourth times y. So according to the product rule, I'm multiplying, I'm going to write this as the square root. I'm going to take the radicands and multiply them together. I'm just putting them together, putting my like bases together and putting the numbers in the front. And so now this becomes the square root of 36. 18 times 2 is 36. X to the fourth times x to the sixth is x to the 10th. Y to the fourth times y is y to the fifth. Because remember, you multiply like bases, you add exponents. 4 plus 1 is 5. 4 plus 6 is 10. And now I'm going to use a product rule to simplify this. So I get the square root of 36 times the square root of x to the 10th times the square root of y to the 5th. And what's the square root of 36? 6. What's the square root of x to the 10th? Remember, when it's even, that's the easy kind. X to what power times itself is x to the 10th, x to the 5th, right? Now let's go ahead and talk about this one. So we have the square root of y to the 5th. So we have that. So that exponent is odd. So 5 is not divisible by 2. So I need to rewrite this. So this will become. So remember, you find the largest number less than 5. That's even. So it'll be y to the 4th. So this is y to the 4th times y. So and then I'm going to use the product rule here. So it'll be the square root of y to the 4th times the square root of y. And what's the square root of y to the 4th? Once you get that even exponent, it's easy. Y squared times itself is y to the 4th. And you get y squared, square root of y. And that goes here. Y squared, square root of y. And there's your answer. Okay? That's it. Okay, number 10. Number 10, we have 3 square root of 5 times 2 square root of 40. 3 square root of 5 times 2 square root of 40. Okay, so let's use a product rule. First of all, 3 times 2 is 6, correct? And then times the square root of 5 times 40, right? Okay, and then 5 times 40, what's that? That's 5 times 40 is going to be 200. Okay, now ask yourself, can I simplify the square root of 200? Is there a perfect square that goes into 200? And let's use the largest. Okay, now all of you should see that the largest is 100. 100 is a perfect square. So let's go ahead and use 100. So we get 6 times the square root of 100 times 2. And then using the product rule, I get 6 times the square root of 100 times the square root of 2. And then, so this becomes 6 times the square root of 100 is 10, square root of 2. And then we're almost done with the answer. 6 times 10 is 60. So I get 60 square root of 2. Okay? All right, let's look at this one. So this is going to be number 11. Let's put number 11 here. So number 11, we have 3 square root of 7y cubed times the square root of 7y. All right. So let's use the product rule on here. So this is going to become 3 times the square root of 7 times 7. And then times y cubed times y, right? Okay, so I get 3 times the square root of 7 times 7 is 49. Y to the third times y is y to the fourth. And now I'm going to use the product rule again on here to rewrite this, because I need to simplify this as I can. So I get 3 times the square root of 49 times the square root of y to the 4th. And then the square root of 49 is 7, so I get 3 times 7. And then notice this is even, right? So that's the easy kind. So that's going to be y to what power? What's the square root of y to the 4th? It's just y to the 2nd. 4 divided by 2 is 2. Y squared times y squared is y to the 4th. And so therefore my answer is going to be 3 times 7 is 21. So you get 21y squared. Okay? All right, so that was number 11. Okay, let's look at number 12. Okay, number 12, I have the square root of 5x squared y, that's a y, times the square root of 35 x to the 5th, y to the 8th. Okay, so again, using the product rule, I'm going to get 5 times 35, and then I'm going to get x squared times x to the 5th, and then I'm going to get y times y to the 8th. Okay? And again, you can skip this step. So you could have gone from here to here. You could have gone and said, all right, 5 times 35, just use your calculator, 5 times 35 will give you 175. But remember, you got to say square root. And then x squared times x to the 5th, when you multiply like bases, you add exponents. So 2 plus 5 is 7. And then y times y to the 8th, again, when you multiply like bases, you add exponents. 1 plus 8 is 9. Okay? And then we got to simplify this now. So to simplify this, I'm going to use a product rule again. So I'm going to get the square root of 175 times the square root of x to the 7th times the square root of y to the 9th. And then let's go ahead and deal with each one. So let's look at the square root of 175. Let's do that here. So for 175, it looks like 25 will go in, actually 25 will go into because the last two digits 75, but is that the largest? Let's see, 175, I'm just doing 175 divided by 25, and I get 7. Yes, and so the only perfect square that goes into 7 is 1. So I'm going to rewrite this as the square root of 25 times the square root of 7. Now let's talk about x to the 7. Let's kind of talk about that right here. So the square root of x to the 7. Do y'all agree that the square root of x to the 7, remember this is odd, so that's going to be the square root of, so what's the largest number less than 7 that's even? X to the 6. So that's x to the 6 times x is x to the 7. And then using the product rule on this, I get the square root of x to the 6 times the square root of x. And now what's the square root of x to the 6? X to the 3rd. So this is x to the 3rd, square root of x. So that goes here. So this is x to the 3rd, square root of x. Okay? And let's go by the square root of 9. So let's do that here, right here. Square root of x to the 9th, square root of x to the 9th, I mean y to the 9th, excuse me. Square root of y to the 9th. Okay, again, what's the largest number less than 9 that's even? So 8, right? So this becomes the square root of y to the 8th times y, which I can rewrite as the square root of y to the 8th times the square root of y. And what's the square root of y to the 8th? Y to the 4th. So y to the 4th, square root of y. Remember, you can't simplify the square root of y because the exponent now is 1 and 1's less than 2. All right, so that becomes y to the 4th, square root of y. Okay, now, you can't leave your answer like this, right? First of all, square root of 25, I can simplify, that's 5. Okay, so let's just kind of write the 5 right here for right now. Okay, so that's 5. But the other thing is that you remember you can still use a product rule on this. See that I'm underlining? Look, I'm underlining this. This times this times this. Okay, so I want you to think about this. I'm going to put that here. Okay, right here. Okay, look. The square root of 7 times the square root of x times the square root of y. I can use a product rule on here, right? Okay, I can write this as 1 square root just by multiplying the radicands. All of these are square roots. The indices are the same. Each one's a 2. So that means I can rewrite this as the square root of 7xy. Okay? And so therefore the answer is going to be 5 times x cubed times y to the 4th times the square root of 7xy. 7xy. That's the answer. Okay? All right. So, yay. Almost everything we've done at this point did not have so many of these factors, but now you know what to do. So when you still have square roots, you got to write as 1 square root, though. You still got to make this look as simple as possible, as simplified as possible. Okay. All right, and then let's look at number 13. Let's do a couple more. So this is going to be number 13. So let's say number 13, I had this. All right, I have the square root of 6n to the 9th times the square root of 24n to the 11th. Okay, so that's not going to be as bad as this one. See, this one was a little bit more complicated because I had many variables. I had 2 variables, right? And then it turned out that when I got to this point right here, both of those exponents was odd. So that's why you ended up with for this one you ended up with the square root of x, and for here you ended up with the square root of y as well. Okay, so that's why it looked so messy. Okay, here it's not going to be that bad. Okay, so let's use the product rule. So this is going to be the square root of. So remember, the product rule says that as long as the indices are the same, you can write this as 1 square root just by multiplying the radicands together. So 6 times 24. So remember, all you got to do is just well, let me write it out. So it'll be 6 times 24. But almost all of you will just skip this step, and you'll say, in your calculator, you'll say 6 times 24, and you get 144, right? And then you're going to say n to the 9th times n to the 11th. But most of you are going to skip this step and just say I'm multiplying like bases at exponents, so it'll be n to the 20th power. And now that's easy because look, so using a product rule, I get the square root of 144 times the square root of n to the 20th. Well, 144 is a perfect square, so what's the answer? 12. 20 is an even number, so that's easy. So that we n to what power? N to the 10th, and there's your answer. Because remember, n to the 10th times n to the 10th, n to the 10th times n to the 10th is n to the 20th. Okay? So that's why when it's even, it's so easy to deal with. And so that's the answer there. Okay, now I just want to show you something real quick, and then we'll stop with this lesson. Here's the situation with this. You see how these numbers, these radicands are large? So for every problem we've done, every single problem we've done, 1 through 13, the first thing I did was I wrote it as 1 square root using the product rule. And so if I do that, I want to show you something. I will have the square root of 63 times 175, right? And so 63 times 175, if I use a calculator, 175 times 63, that gives me this, 11,375. That is outrageous, right? And so you're like, well, God, that's going to take me a long time to find the largest perfect square that goes into this number, right? Yeah, so what I'm now saying is this. If once you get to this point and this is so outrageous, what I would then do is go back to the original problem, and then let's just go ahead and simplify each one first, and then we're going to use that product rule. Okay? So in other words, it may look like this, and then we're going to get to this point. All right? So let's look at the square root of 63. What's the largest perfect square that goes into 63? Okay, 9. So I get the square root of 9 times what? 7. Okay? And then let's look at 175. I think 25 is the largest. Let's just check. So 175 divided by 25, and I get 7. So that's the square root of 25 times 7, right? And so using a product rule, I'm going to get the square root of 9 times the square root of 7 times the square root of 25 times the square root of 7. I'll see that. And then I can simplify the square root of 9. That's 3. I cannot simplify the square root of 7. I can simplify the square root of 5. That's 5. And I cannot simplify the square root of 7. And so now I'm going to multiply these. 3 times 5 is 15. So remember, you're saying 3 times 5. And you can skip this step. And then you're saying times the square root of 7 times the square root of 7. And then now using a product rule, I can write this as 1 square root. 7 times 7 is 49. Correct? 7 times 7 is 49. And so I get 15 times, and then the square root of 49 is 7. And then notice I don't have any square roots left. So So when I multiply that out, 15 times 7, I get 105. So what that means, see, I don't have any square roots left. So what that means right here, and you would not have known that unless you just checked to see if it was a perfect square. What that means that this is a perfect square. So in other words, if you just go ahead and see, well, that's an outrageous number, so I'm hoping this is a perfect square. Well, take the square root. So watch, square root. Oops, wrong one. Let me do it again. Square root. Okay. 11,375 equal. Oops. Let me make sure I wrote this correct. So let me multiply this again. 63 times 175. Oops, I'm sorry. It's 63 times 175 is, I'm not sure what I did, but that's the square root of 11,025. Okay. So now let's do it again. So the square root of 11,025, press equal, and you get 105. But it's not always going to be a perfect square. So you may need to do this. Okay? All right. So I just wanted to bring that up, that if when you multiply using the product rule and this becomes a ridiculous number, then simplify each one as much as you can, and then you go from there. Okay? All right, so that is the lesson on multiplying square roots. And notice that it should be fairly easy for you now. It's not a difficult concept anymore for you. You know what to do. So that's the end of the lesson on multiplying radicals.